In our last settings video, we just started to create our settings menu. With the video resolution and display type completed, we could keep going and implement several other common settings that the user can manipulate. However, before we continue, we have to talk about scriptable objects and binary saving. Before we start, I highly recommend that you watch the following video. Ryan Hipple does a fantastic job explaining scriptable objects. With scriptable objects, creating projects and systems that are modular, editable, and debuggable is easily achievable. It will save you a lot of time in the long run, so please check it out. If you do not watch it, this video will give you the gist of how we will utilize scriptable objects for our settings menu. Scriptable objects are serializable Unity classes that are similar to modern behaviors with no transforms and are saved as asset files. When we collect data from the user or by the system themselves, i.e. default values, we can store this data within scriptable objects and reference the object whenever we need to access the data again. As an example, say the player sets screen resolution to 1152 by 864 and the display type to windowed. This data can be stored in the scriptable object, and when we move into another scene, we can retrieve this data to populate our settings menu again and show the correct values to the player. Now, what about binary saving? What will we use that for? Well, let's say the user closes their game. Where does the data go? Scriptable objects do save their data within the project editor when you stop and replay the scene, but they do not save their data when the project is built and the user restarts their game. So we cannot just store them there. This is where we generate a binary file to save our data outside of our game. We will now explain the data workflow. We first need to create our scriptable object. This scriptable object will hold all of our data. Right now it doesn't have any values that we can use, so we will use several scripts to find viable data. We start inside our settings script. This script will interpret any data stored inside our scriptable object. Since there is no data at the moment, we use this script to call a function inside the load settings file script to handle the population of our scriptable object. Inside load settings file, a function called instantiate settings will call a function inside our save and load file script to find existing files. If the file exists, then the file will be deserialized, the data will be returned to load settings file, and the scriptable object will be populated with the given data. If the file does not exist, then we will populate the scriptable object with default values and create a new settings file by calling saveSetting from the save and load file script and serializing our settings class. We can now go back to our settings script and interpret the data inside the scriptable object. Hitting save will repeat the same saving process as discussed before, and that pretty much summarizes our process. Now, why binary instead of player prefs or JSON? This is because binary file saving provides one more extra layer of protection for our data. Binary file saving is not entirely reliable for data encryption, but it is still a good practice for hiding data from the general public. So why use scriptable objects instead of just reading off of the binary file? Well, this is mainly a design choice. Reading off of the binary file and creating a static class that it holds all the allotted data is very much doable. It would persist just like scriptable objects. There's a great article regarding game architecture with scriptable objects compared to singletons. I would highly recommend giving it a read. The way we are handling settings is definitely not the only way to do it. It is your decision as to how you should build up your game, whether it is to base your projects around scriptable objects or by other means like with singletons. With that all explained, let's apply this to our current settings project. Let's first create our scriptable object. We will create a new C# script and call it SOSettings. Open it up and delete the start and update function. Surround this class with a namespace. I went with tbob. We will also have to do this with our settings script, so please do that now. Anyway, instead of inheriting from a modern behavior, we will change it to inherit from the class scriptable object. We also need to add the create asset menu attribute above our class. Now, this is where organization is very important. When you end up creating multiple scriptable objects, things can get really messy if your asset menu is not properly organized. Like, look at this, what does this even? Try to think of a system that works best for you. In this case, we will create a path called SO, and under our SO, we will create a settings tab. Now, before we continue, we have to talk about registry keys again. It was previously discussed that the resolution and display type were saved inside the registry. When we build the game and play the game, the player stores the last used screen size and resolution inside the Windows registry. The player will then read this key upon starting the game again. I mentioned that we would stay away from using the registry key, however, a problem came up when trying this. During the Unity splash screen, as quoted by Carl Jones, you won't be able to do anything immediately when the splash screen shows, as this is before the engine is ready, but you may be able to get a script running towards the end once everything is loaded, probably the last second or so. Therefore, trying to run and execute set resolution before the splash screen was just not going to work. So we will just have to rely on this key to manage our resolution and display type. With that being said, within our class, we will add the header attribute and call it video settings. Under this header, we will create 3 public variables. 2 of them will be public integers representing the width and height of the game, called width value and height value respectively. The last one will be a string called display type value. We will come back to the script at a later time. Back to our editor, we will create a folder to hold our scriptable objects. For now, we'll call it Scriptable Objects. If everything was done correctly, we will then create our scriptable object by right-clicking, looking under SO, and hitting Settings. You will now have your scriptable object with your height, width, and display type variables displayed. Just a reminder that the scriptable object will be referenced by the main settings script to determine what values each component or setting should be set to. Let's create another C# script called settings file. We'll start by removing the start and update function. Surround this with the namespace used before and remove the monobehavior inheritance. Now, what we're doing here is creating a serializable class that takes data from the scriptable object and stores them. This will later be formatted and created into a binary file. Let's add the serializable attribute to the entire class. Now, inside this class, we'll create 3 variables. Similar to how we did the other scriptable object, we'll create 2 int variables and 1 string variable. The 2 int variables will be called screen width and screen height, and the 1 string variable will be called display type. Within this class, we will create a function called settings file, with the parameter accepting the SO settings scriptable objects called set. Within this class, we will populate the variables by taking the values found in the settings scriptable objects. In this case, within the function, we will make screen width equal to set.width value, screen height equal to set.height value, and display type equal to set.display type value. With that, we're done with the script for now. Let's create our save and load system now. We'll start by creating another C# script called save and load settings. Here, we will actually save and load our binary files. Again, delete the start and update function. We will surround this class with our previously made namespace and remove monobehavior. Be sure to make this class static. Now, include the following 2 namespaces to this script, using system.io and using system.runtime.serialization.formatters.binary. Inside our class, we will start by creating a static function that will save our settings. We will call this as saveSettings that will receive an SO setting object called set. Inside this function, we will first need to create a binary formatter and use it to serialize our data. Once created, we need a path to save our file. By using application.persistentDataPath, we will essentially save the file inside a directory that will be consistent for any computer. Whether they use Windows, Mac, or any other OS, persistent data path will find a directory that is suitable for the device and returns a directory string. We can now personalize the file name to whatever you want, with whatever extension you want. We decided on using /setting.hjg for HamJoyGames. You may also want to add a debug log to check the directory path of your file. From there, we have to open up a stream for our file. FileStream opens up the synchronous and asynchronous read and write operations for our files. In our case, we will create a stream and attempt to create a file at the created directory path. If it exists, it will be overwritten. If not, then we will create a new one. Now we must retrieve our data. We will create a new settings file object and pass in the scriptable object. Our settings file script will be a serializable class that will take all the data from the scriptable object and store them inside primitive variables. We then serialize the data with our stream and settings file object. With all that done, the file has been made. Be sure to close the stream after use. So now, let's create our load function. We will call this as load settings that will be static and return a settings file object when called. In the function, we must figure out if the file exists at the designated path. Be sure it is consistent with the path created for our save function. If the file exists at this path, then we can load this setting. Inside this if statement, we started off by using a debug log to tell us that the settings file has been found. We will create a new binary formatter object that will be used to deserialize the file of interest. We will create a stream for the existing path and open the file. We will now deserialize this opened file stream and store the data into the settings file object. Be sure to cast the deserialization as a settings file type. We will close the stream and return this object. If the file does not exist, we will return null and tell the system that we need to create a file with variables gained from the registry. With that, we are done with this particular script, and we don't need to revisit this again. Back into the editor, we need to create another script that will actually load the saved data to our scriptable object. We will call the script load settings file. Delete the start and update function and surround the class with a namespace you created. Ensure that this class is static and monad behavior is removed. We'll start by creating a public variable of type SOSettings called SOSettings. We'll then create a public static function called initiateSettings. Inside here, we will access the load setting function inside our save and load settings script and see if a file currently exists. If the file does exist, we will assign the scriptable object with the data returned from load setting. In this case, SOSettings.widthValue is equal to data.screenWidth, SOSettings.heightValue is equal to data.screenHeight, and SOSettings.displayTypeValue is equal to data.displayType. If the file does not exist, we will take the last state of the resolution and display type. These are recorded by the registry and you can be referred to again upon startup. In this case, we want to access what the screen's last resolution was and assign the appropriate width and height to the scriptable object. We will also do the same for the display type. We will now start cleaning up our settings script. We'll start by creating a public variable for our scriptable object called settings. We will delete resolution initialize and screen initialize. Under our screen options function, we will assign the drop-down value under each mode and assign the display type string to our scriptable object. Note that this function does not actually execute the screen change, it only handles the drop-down interaction. Functionality for the resolution and display type will come later. In our start function, we will delete the screen initialize and resolution initialize function calls. We will pass the scriptable object to the load settings file script to read and write on. We will also call the initiate settings function from the same script and call load settings that we will create now. In this function, we will essentially look through all the viable resolutions and match it with what we have on our scriptable object. Remember, this scriptable object was populated by a load settings file. When found, we will ensure the resolution reflects the right resolution and refresh it. We will also access the screen options function to ensure the correct dropdown for the display type is shown. Before we continue, we need to add some more features to our menu. Right now it looks pretty ugly. We know how to set up the UI, so it is up to you if you want to modify how the settings menu looks. Try playing around and seeing what you like. We will also add new things like a save button and a pop-up menu. The save button is pretty self-explanatory. For the pop-up menu, we will create an empty game object, and under this game object, we will create a panel. Under the panel, we will add a background image, and under this image, we will add the following: 2 buttons and 2 texts. Name them however you wish, but I name them as button accept, button revert, text warning, and text countdown. When changing resolutions or display types, games usually prompt the user to either apply the changes, revert back to normal, or automatically revert after a set time. This is a very common feature for resolution and display type functionality due to the off chance that the chosen resolutions or display type causes problems for the player. This is why the pop-up is needed. Back in our settings script, we will need to create a number of new variables. We'll start with the game objects. Create one for the pop-up game object. Next is the buttons. One for the save button, which will be used for later settings, one for accepting the pop-up window, and one for reverting from the pop-up window. We will then create a text variable for a countdown. Under our private variables, we'll add 3 more entries. 2 of them will hold the previous index for the resolution and display type in case they want to revert their settings, and the last one will establish how long we want the pop-up to last, in this case, 15 seconds. Under the start function, we will ensure that the pop-up game object is off. Assign the previous index for the resolution and display type as the current drop-down values. Reminder that the current drop-down values were assigned from the load settings function. Inside each of the on value change dropdowns, replace each of them for a function that we will create called pop-up handler. Both will send their current dropdown value and the dropdown themselves. We will also create an on-click event for the save button, but this button will make more sense for the other settings in the future. In the pop-up handler, we will start by enabling our pop-up and removing any on-click events from the apply and revert buttons. Now, using the passed-in dropdown, we will change the operation of the buttons depending if resolution or display type was changed. If the resolution dropdown was sent in, i.e. the resolution dropdown was changed, then we will call a function called setScreen to immediately change to the new resolution. Under the setScreen function, we will use the index that was passed in from the resolution dropdown index and set the resolution to whatever values we chose from our dropdown menu. We will then save these values into our scriptable object, set the dropdown to display the correct value, refresh it, then save the data from our scriptable object into our file. Now we will add events to our buttons. At this point, the resolution was already applied and saved to our file. So when we hit apply, it will simply record the current index as our previous index and close the pop-up. This will be changed later on, but this is what is happening right now. Under the close pop-up function, we will just disable our pop-up menu game object. For the revert button, we must call the setScreen function again, but this time we will use the previous index that we stored and revert our process. We will also close the pop-up at this point. Now, if we change the display resolution, then we will call a function called setDisplay. Under setDisplay, we will find the text string connected to the index that the user chose in the dropdown, pass it to the screen options, and apply the new screen mode to screen.fullscreen mode. We will then save this change. The rest of the else statement is very similar to how we did the resolution dropdown, but be sure we utilize setDisplay and change the previous displayed index rather than the previous resolution index. We now have to implement our timer. We will start a coroutine called timer and pass in our dropdown of interest. We will create an IE numerator and assign our current timer with our maximum pop-up timer. If the current timer is greater than 0, then we will continue to count down every second. When it reaches less than 0, we will apply the same revert functions for our resolution and display type depending on which dropdown was passed in. We will then add a stop coroutine at the end of our close pop-up function to stop the function from continuing its countdown. We will now do some small fix-ups for our code. It has come to my attention that inside the setDisplay function, we need to call an IE numerator to change the display type. There seems to be a small issue with resolution when moving from exclusive full screen to anything else. From what I've searched, it appears to be a frame-dependent issue regarding resolution and display type, so a workaround for this is to set the resolution at the next fixed update call. Next, change the drop-down strings to match the given names shown in the project manager, and call the setResolution function under our loadSettings function using our scriptable object values. We also condensed our code to be a little more neat. Notable changes include how we apply and revert our drop-down and display type. They are now condensed into two functions being passed in variable parameters depending on the situation. Finally, inside the editor, attach the correct objects, buttons, and text to the settings script. With that, we should be good to test. When we first started, you may notice that the scriptable object might have some odd values. These values are actually based on the editor's game size. Since we do not have a registry key built yet, and we do not have a settings file at start, the values take on the window size and therefore the resolution cannot be found in the dropdown and defaults to the first value. Upon more testing, you'll notice that the window and resolution isn't actually changing. This is also intended as window and resolution only occurs in build. We can check to see if the file is being created, and we can find the directory using our debug log. Let's start with a fresh build. Delete the settings file as well as the registry keys related to the project. Be careful though, since this is a fresh project with nothing else requiring the registry, I deleted all the keys in the file. It may look different from yours. Be sure to just delete the full screen mode keys and the resolution keys. We can now build the project. Open the game and you'll notice that the video resolution and display will match the default values you initialized in your project settings. Now you can test the settings. Feel free to try the exclusive full screen too. I had trouble recording exclusive full screen, which is why I'm only showcasing windowed and full screen window. Test the timers and see if reverts are working properly, and also test to see if reopening works correctly as well. With that, we successfully implemented binary file saving and scriptable objects to our project. Well, I hope you liked this video. Scriptable objects may be a bit daunting at first, but once you get the hang of it, the possibilities are endless. We will be constantly accessing some of these scripts to add new things that need to be saved in future videos. In the next video, we will be adding brightness and render distance to our settings menu. With that, we have finally covered a large chunk of the settings menu setup. Thanks for listening, and I'll see you next time.